right, so here's what you should have gotten for that top box. So again, with these exponents, top numbers are power, bottom number is our root. So if you're doing any root that isn't a square root or a cube root, in your calculator, if you push the math button, choice number 5 is what allows you to put in any root that isn't a square root or a cube root. So that's how we can get that. And then down here on the bottom, this was our power to a power rule. So that means you have to multiply them. So 6 times negative 2 is where my negative 12 came from. Negative exponents are never okay. We always have to take care of those and make them positive. So in this case, it made my x move into the denominator of a fraction, and now my exponent is positive. So 1 over x to the positive 12. Here, when I multiplied for that second one, 1/2 times 2 gave me 1, so it's x to the first. Do I have to write that exponent of 1, though? Nope. I could just leave it as x. That's the same as x to the first. You don't have to write the 1, but if you need to, go ahead and write it. And then this one, negative 2/3 times negative 3/2. Negative times negative makes it positive. Multiply your top, multiply your bottom. So 2 times 3 gave me 6. 3 times 2 gave me 6. 6 over 6 reduces to a 1, so it's x to the first again. So we're going to be using this power to a power rule a lot for our notes today for our new stuff. What we're going to be doing is we're going to be solving some equations that have fractional or negative exponents to them. So if you are solving an equation and your x has a fraction exponent or a negative exponent, what you want to do first, you want to isolate the expression containing the exponent. So you want to get that completely by itself. So add or subtract any numbers and then add, multiply or divide by any numbers. So once you have it by itself, you want to raise both sides of the equation to the reciprocal power. The reason why we do that is because we're trying to get an exponent of 1. So if I have a reciprocal, like for example, right here. These are reciprocals. It's the same thing, it's just one's flipped from the other one. So when you multiply them together, they ultimately end up equaling a 1. And then you solve the remaining equation if necessary and check the solution in the original problem. So let's take a look at our first example here. We have x to the 1/2 equals 9. So my x is already isolated. That's already by itself, so we don't have to take care of that first step. But to get rid of that 1/2, I need to raise both sides of my equation to the reciprocal power. So the reciprocal of 1/2 would be 2 over 1. But again, we don't have to write the over 1, so we can just write it as 2. So 1/2 times 2 makes that x to the first power, which is what we want. So then on the other side, 9 squared is 81. So x equals 81 is our answer here. So then just a quick check. 81 to the 1/2 really means that we're taking the square root of 81, which is in fact 9. So that is exactly what we wanted. So number 2, getting just a little bit harder. We have to get the x by itself. So first thing I'm going to do is I'm going to subtract that 1, just like we would in any linear equation. Subtract your 1 over to get x on its own. So now since my exponent there is a fraction, I'm going to raise both sides to the reciprocal of that. So the reciprocal of 2/3 would be 3/2. So now 2/3 times 3/2 gives us x to the first. Again, that's what we wanted. So then over here, again, power over root. So that means it's the square root of 4. And then we'll cube it. So what is the square root of 4? 2. And then what's 2 cubed? 8. And then just a quick little check. So if I plug in 8, this means I'm going to take the cube root of 8 and square that. The cube root of 8 would be 2. 2 squared is 4. 4 plus 1 does in fact give me the 5 that we had over there. So it does check out. Let's try a couple more examples. So looking at number 3, some people get a little confused on this because I'll ask them, is your x by itself? And they're like, yes, it is. But it's really not, though. It's got that 3 in front. We got to get rid of that 3. So we got to divide both sides by 3 so that my x is truly by itself now with the exception of its exponent. So 96 divided by 3 gives us a 32. So now we do the reciprocal power. So this to the 2/5, and I'm going to do that side to the 2/5. Now we simply have x by itself, which is what we wanted. On the other side, we got to figure out the 5th root of 32 and then square it. So what is the 5th root of 32? Use your calculator to help you if you need to. So math, choice 5, I want 5th root of 32, and then we want to square it, so we get 4. So we get x equals 4 is our answer. So number 4 is just a little bit different because this time we have a negative exponent. It's just a negative 4. But the steps are going to be the same. So is my x by itself? Yes. So I'm going to raise both sides to the reciprocal power, which would be negative 1/4. Since that original exponent was negative, its reciprocal will also be negative because negative times negative makes a positive, which is what we want. So now I have just x, because negative 4 times negative 1/4 gives me positive 1. So then because it's negative, that would make it a fraction. So it would be 1/81 to the positive 1/4 now, which is the 4th root of 81. So what is the 4th root of 81? Somebody say it. 3. So x equals 1/3. So then our last one here. So for number 5, change it up again just a little bit because it's not just x to the exponent, it's x plus 1. So is everything that has the exponent on it by itself? Yes, because this is basically like one whole thing. There's nothing in front of it, there's nothing at the end after it saying plus or minus. So yes, this is by itself. So I'm going to raise both sides to my reciprocal power, so it's the 2/3. So that gives us x plus 1 now on the left side. And then we want the cube root of 64 squared. What is the cube root of 64 squared? 16. And so now our last step, subtract the 1. So we get x equals 54.